Okay, so I'm going to do the beginning of the worksheet. I'm going to do, I think, 4 or 5 different short PowerPoints regarding the reaction worksheet. The first one will be, second one I did already, combustion. Second one will be single replacement metal plus ionic compound. Okay, what you need to do is, by the way, you hear a lot of banging. That's because they're replacing the shingles on the roof, and that's what's going on here. So what we need to do is I'll give you the reactants. You need to finish the word equation, uh, balance the equation, and show what is being oxidized. So let's do the first equation, which is silver plus potassium nitrate. So all you have to do is swap the names. So silver replaces potassium. Potassium comes out. It doesn't matter how you say it. You could have said silver plus potassium nitrate yields silver nitrate and potassium. Okay. The initial chemical equation is you just replace the words with the symbols. Silver, and anytime you have an element that's all by itself, will always have a zero charge. Potassium nitrate from our material we just got done with. K, so potassium nitrate is K plus, NO3 minus, crisscross charges, or don't, because they're the same, so you're all right there. Potassium is all by itself, so it gets no charge. Notice now that it has no charge when it's not an ionic compound. And silver nitrate is just like you would find it if you gave it to you on a test, so it's Ag plus, NO3 minus, and same charge, so no subscripts. Okay, it's already balanced. Okay, so nothing there. So what I want to do now is look at what's being oxidized, what's gaining and losing electrons. So I set up this table. Silver goes from having no charge to a plus charge. That means it got more positive, and the reason why it got more positive is because it got less negative or lost electrons. So losing electrons is oxidized. Okay, we went over that. Oil rig oxidized is losing. And reduced is gaining. Okay. The potassium goes from having a plus charge to having no charge, so it got less positive. And the way you can get less positive, become more negative, and the way you become more negative here is to gain electrons. And so gaining electrons is reduced. And then the nitrate, NO3 minus, retains its charge, and so nothing happens to it, so we call it the spectator ion. Alright, next problem. Potassium phosphate plus barium. Okay, finish the word equation. Barium phosphate plus potassium. You notice I switched them around here. Okay, so it doesn't matter. 3 plus 5 is equal to 5 plus 3. And that's math, and it's the same in chemistry in terms of this. I think it's called the associative property or commutative property, one of those two. But just know it doesn't matter the order that you, at least you put these guys in. It does make an order which side you put them on, though. So potassium nitrate is K plus PO4. Phosphate has 3 minus charge. Potassium has a plus charge. Crisscross charges, 3 here and a 1 here if you like, but you don't need to do that. Barium is all by itself, no charge. Barium phosphate is Ba2 plus. Now barium has a 2 plus charge because it's in an ionic compound. Phosphate's 3 minus, crisscross charges, and you got Ba2, Ba3, PO4 2, and now potassium has no charge on it. So that's your initial equation. It's not balanced. Okay, because you can see there's 3 bariums over here and so forth. Okay, now the way that I balance these, I start with the negative ion. Okay, so I'm going to start over here, and I notice that there's 2 phosphates. Okay, so what I'm going to do is I'm going to go over on the other side and put a 2, okay, in front of the K3PO4. Now there are 2 phosphates. Okay. Now I'm going to stay with this guy over here. Okay. Now I'm going to count up how many potassiums I have. So I have 2 times 3 is 6, so I need to have 6 potassium. So I come over here and I put a 6. Okay, second step is to get 6 potassium. Okay, and the first step was to get 2 phosphates. Alright, and then finally, I think, so I'm right here. So what I'm going to do is look at the barium, because that's the last thing to balance. And I notice there's 3 here, and I'm just going to simply come over here and put a 3. So the third thing is give 3 bariums. And you're done. Okay, so notice the pattern. I start with the negative ion, come over and fix it on the other side, and then whatever it's attached to, I fix that on the other side, and then I finish up the last element. Okay, as far as what's being oxidized and reduced, potassium goes from having a plus charge to having no charge. So that means it got less positive, and the reason it got less positive is because it gained electrons, so it was reduced. Barium went from 0 to 2 plus, so it got more positive. And the reason it did that is because it lost electrons, so it's oxidized. And phosphate, nothing happens to it, it goes to 3 minus, 3 minus. So what you're getting here is barium is sending electrons to the potassium. So there's a transfer of electrons. Alright, and the last one. Okay, so you have copper plus iron sulfate. That's your reactant. I gave you that. So just swap. So the iron takes the copper takes the place of the iron, and iron comes out. So the initial equation is Cu. So when an element is outside, it's not part of an ionic compound, no charge. The iron sulfates, just like we learned from the material we covered, iron is 3 plus, sulfate is 2 minus, crisscross charges, you get 2 and 3. Okay, iron now has no charge, and sulfate is 2 plus and sulfate is 2 minus. They're the same, so you don't have to do it. Don't have to crisscross. Okay, so this is your initial equation. It's not balanced. So let's fix it. So what I'm going to do is start with the negative ion. So I have 3 sulfates. So what I'm going to do is I'm going to come over here and put a 3. So first thing is to get 3 sulfates. Okay, now I have 3 coppers. Remember, this 3 distributes, goes to sulfate and the copper. So now I have 3 coppers, so I'll just come over here and put a 3. Okay, so the second thing is to get 3 coppers. And then finally we got to fix the irons. I need 2, so I'm going to put 2 here. There you go. Okay. Hopefully you see the patterns. So start with the negative ion and then fix it. So this 3 fixes the sulfate here. Okay, now I have 3 coppers, so I have to go over here and fix it. Okay, then finally take care of the irons. Okay, copper goes from no charge to having a 2 plus charge. Should be a 2 in here. So it became more positive, so it lost electrons, it's oxidized. The iron goes from 3 plus to no charge, so it got less positive. And the way it got less positive, it become more negative. It was reduced, and then sulfate, nothing happened, so it's a spectator. Okay, so that's it for this, for these 3.